All right, hello. So this video is all about basically what this first situation is showing. It says you own a miniature model of the Statue of Liberty in your backyard. If you notice, the mini one is actually not so mini since it's 61 feet tall. But assuming that the two figures are the same, and the one on the right is the actual Statue of Liberty, try to find the height of that one. All right, so we're assuming that they're similar. Um, what we're gonna do today is we're gonna figure out what that h would be, and now maybe you can do that in your head right now, but we're gonna show how you can do that, um, and similar things like that by setting up and solving proportions. So that's our goal for today, to be able to solve proportions, and we will also be setting some up. All right. So I want you to think about this. If you buy one can of pineapple chunks for $2, then how many can you buy with $10? Okay, so I want you to think about what we've been talking about with the ratios, and I want you to set up a couple ratios that would be we can turn into a proportion. All right, so let's look at what we have here. It says we have one can of pineapple chunks for $2, and we want to know how many for $10. So let's set up that first one. If you have one can, you can set up a ratio. One can is $2. All right, whoops. One can is $2. Um, and we know that we have $10. We don't know how many cans, so we'll do n cans for $10. All right, so here I set them equal because they should be proportional. It'll stay the same. It'll be consistent for however many cans it will be. It's not going to be one can for $10 then, because we know one can is $2. So we got to figure out how many cans get you to $10. Now there's a couple different ways you can do this, and I want to go through these couple different ways. So first of all, I just want to quickly review with you what a proportion is. A proportion is exactly what we just looked at before, and the definition here is an equation stating that two ratios are equal. Okay, if things are proportional, we can set the ratios equal. Um, we know, or if things are similar, we can set them equal to each other, and then we're going to find, usually we have a missing piece, and we have to solve for that. But the proportion is just having two ratios that are set equal to each other. All right, and solving a proportion. Now, given the proportion that we just did, I believe I am using that one yet, but let's get rid of that. Solving that proportion, you can use two different methods. You can actually use three different methods, but we're going to just talk about two of them today. And the first one is what you know how to do already, what we've been doing with solving equations. So if you remember back to that multiplication property of equality, that states that you can multiply the same thing to both sides of an equation without changing the outcome or changing how it's going to be. You can do that. If you do the same thing to both sides, you can do that. All right? So we have our equation here, or our proportion here. I left out if you notice, your one can to $2 is n cans to $10. I use the same numbers, only I left out the labels. So it's 1 to 2 is equal to x over 10. Okay, so if you think back, we're going to try to solve for this x. So we got to get rid of everything over here. And if you use the multiplication property of equality, and note that it only works if variables on one side of the equation, on the numerator of one side of the equation. And we have it on the numerator here, so we can try to get rid of this 10. And to do so, using the multiplication property of equality, we're just going to, because this is division, we're going to multiply both sides by 10. And if you notice, this will be actually 10 over 1, so that cancels out because one's on top, one's on bottom. Then we have 10 times 1, which is 10 divided by 2 is 5. So we have 5 equals, what's left over here is x. All right, so we're done. X equals 5. That's just one step, getting the x by itself, multiplying both sides by 10 to undo that division. All right, so that's the first method. And if you'd like to, I do have the solving proportions worksheet on Moodle, and you are welcome to practice that using that in numbers 1 through 9, just trying a few of those. All right, I'm not going to go through this now. I'm going to actually skip ahead and show you the second method you can do. And the second method is called cross products, or we're going to say cross multiplication. So we're going to say cross multiplication here. Multiplication. So the important part to notice here about cross multiplication is that you multiply the numerator of each, I should say of, with the denominator of the other. So if we have the numerator of 1 all right, sorry about that. All right, so as I was saying, the second method, or this cross multiplication method, you have to multiply the numerator of each with the denominator of the other. So if you look at the numerator here, for number 1, you're going to want to multiply it by the denominator of the other. So 1 times 10, we have 1 times 10 show it over to the right here. All right, then you're going to want to multiply the numerator of the other one with the denominator of the other one. So we're doing cross multiplication here. All right, so that'd be 2 times x, which is 2x, and then set them equal to each other. That's cross multiplication. All right, you multiply the opposites to each other and set it equal. So 1 times 10 is equal to 2 times x, and you just have, really, it's a one-step equation then, because you know you can get this x by itself by dividing both sides by 2. All right, so this cancels out here. You have x equals 10 times 1 is 10 divided by 2 is 5. All right, so different method, pretty much the same number of steps, just as easy to do as method number 1, but either method works, okay? Except for the first method, multiplication property of equality, only works when you have a variable on the top of one of the ratios. Whereas the cross products, or the cross multiplication rule, will work for any type of proportion. All right, so if you want to try that, you can work on numbers 10 through 18 as a little extra practice for that. If not, we're going to go on. I'm going to do a couple more different examples that we can walk through. First thing that I want to show you is just similar figures, kind of like we did at the beginning. I want you to set up a proportion for this and solve for the variable. So in here, the variable is m. You got to figure out what that is. All right. So what is the sides that are similar or corresponding? They're called corresponding sides. I will circle here with the same color. So 3, if you notice, 3 is on the left side, and the bigger figure 21 is on the left side. So those two are corresponding. All right. M is this long side, the hypotenuse, and so is 5 over here. So those are corresponding sides. That's what corresponding sides are, and that's a term worth thinking about. Corresponding just means they go together. So the smaller one, this goes with 3 goes to 21, and I'm sorry, 5 goes with m. So if you want to set a proportion, you could think, I'll do the proportion of the smaller left side to the bigger left side. So 3 over 21 is equal to the proportion of 5 over m. It makes sense because 3 to 21 should be the same proportion or ratio as 5 to m. And you can use either method you want here. to solve. Actually, if you notice here, you can't use the first method because the m is on the bottom, not on the top. So let's do multiplication. So you get 3 times m equals 5 times 21. And if you do 5 times 21, we'll write it over here. 21 times 5, at 5, 10, that is going to be 105. So 3m equals 105. Last step would be to divide both sides by 3. And if you divide that out, m is going to be equal to, I believe it's 35. All right, you can check that. So m equals 35. And if you notice, that does kind of make sense. 5 is almost twice as big as 3. Over here, 35 is almost twice as big as 21. Just not quite. So that's setting up a proportion for looking at figures. What I want to do next is look at setting up a proportion for word problems. Okay, I'm going to give you a couple story problems, word problems here. And this is the very first one. But I want you to note, and this is kind of going along with the last thing that we did, the last situation. When you're setting up a proportion, the labels must line up. Okay, so I'll show you that in a second. Number 1 says, if you buy 1 can of pineapple chunks for $2, then how many can you buy with $10? This is going way back to the first word problem we did. But if you notice here, I set it up 1 can to $2 equals n cans to $10. And the thing that I wanted you to note, and I'll underline it here, is that when setting up a proportion, the labels must line up. So for instance, I have on the top of both proportions, I have the cans, and on the denominator, I have dollars. And that works. That's an okay way to set up a proportion. A not okay way to set up a proportion would be to not, line them up. So what's wrong with this setup? If you did 1 can to $2 equals to $10 to n cans, you notice labels are not lined up or consistent. You have to be consistent. If you're going to have one ratio be cans to dollars, the other ratio also has to be cans to dollars and not dollars to cans. So these should be flipped. All right? So I want you to think about that as we set up some proportions for a couple of word problems here. We might just do one, but it would be very helpful for you to practice more. So first of all, let's look at this one, number 2 here. It says Ming was planning a trip to Western Samoa. All right? Before going, she did some research and learned that the exchange rate is 6 tala. Looks like tala is the currency, the money in Western Samoa. The rate is 6 tala for $2, or 6 tala for $2. We can set up a ratio right away because we know that that's a ratio. So 6 tala to $2. How many tala would she get if she exchanged $6? All right, so let's set up a proportion to figure that out. The only thing is, you got to know what goes on top and what goes on bottom. And if you look back here, you got to keep it consistent. All right, if dollars are on the bottom, dollars are going to be on the bottom on the other side. And then cans are on top for both. So right here, you want to have dollars on the bottom again and tala on the top. All right, so we know we have $6, and we don't know how much tala, so we'll use that as x. All right, so you have to solve for how many tala. And this way, this one you can do either the cross multiplication way or the property of equality. And since we can do the property of equality, I'm going to do that. So right now we're going to multiply both sides by 6 to cancel this 6 out. All right. And you're left with x over here. X tala equals 6 times 6, which is 36, divided by 2, or x equals 18. 36 divided by 2 is 18. All right, so your answer would be 18 tala you could get for $6. All right. Let's try one more. Number 3. Gabriella bought 3 cantaloupes for $7. All right, we can already set up a proportion. 3 cantaloupes for $7. 3 cantaloupes for $7. Very good. There's a ratio. How many cantaloupes can you buy for $21? So we want to know how many cantaloupes. We don't know that yet, but we do know she has $21. So let's put $21 on the bottom so that the dollars are lined up. And that's equal to how many cantaloupes? So let's say X. This one, let's try cross multiplying. All right, so 7 times X equals 3 times 21. All right, or that is also just 63. So divide both sides by 7. X equals 63 divided by 7, which is 9. And we're looking for how many cantaloupes, so 9 cantaloupes would be your answer. All right. So you're just setting up a proportion and solving for that missing piece. All right, I'll let you try the last one on your own. There's one last thing, though, that I want to introduce to you before I let you go, and that is just a multi-step proportion. So we're really just adding one step to what we've been doing. If you notice, we're not just having a variable, the missing variable on one part of the proportion. In this case, we have a variable plus 5 or a variable minus 1. You'll see different types like this where you have a longer algebraic expression on one side, one part of the, more than one part of the proportion. Okay, but in this case, you're going to have to use cross multiplication. All right. So use your cross multiplication to solve the variable. So let's try the first one, and I'll let you try the second one. The first one, if you cross multiply, we have b plus 5 times 10, or 10 times b plus 5. So I want to actually write that out. 10 times b plus 5. And this is how you would write it out, because it's that whole b plus 5, that whole thing times 10. So you'd write it outside of it. That's equal to 7 times 5, which is 35. All right. Now, probably the easiest way for you to do this, and you might see that, well, this is 10 times something. You can divide both sides by 10, but you'll end up with a decimal there on the right side. So I would use your distributive property. You see something with parentheses? Distribute it like this. 10 times b plus 10 times 5, which is 50, equals 35. And then you got 2 steps to do it, so minus 50 from both sides, and you get 10b over here, so those cancel out, equals negative 15. And then one more step to get b by itself would be to divide by 10. Alright, this is good practice for solving equations. And then b equals negative 1.5 will be your answer. Okay, so just using the cross multiplication and then solving. So what I'd like you to do is try this second one all on your own. So if you want to pause it and try it, go ahead. All right, so I hope you worked through this one. We're going to use, again, cross multiplication. And we've got b minus 1 times 9, or 9 times b minus 1. And that's equal to 6 times 7, which is 42. All right. And again, we're going to use some distributing here. You have 9b minus 9 equals 42. When you add 9 to both sides to get rid of this minus 9, remember you have that minus, so you add 9 to both sides. got the 9b over here, and that's equal to, sorry, add 9, it's equal to 51. Now to figure out what the b is, you gotta subtract, and sorry, you would divide both sides by 9 to cross that out. Divided by 9, b equals, I'm not sure on the exact answer, I think it's going to be 5 2/3, approximately. So we'll do 5 2/3. Or you can leave it as 51 over 9. Alright. So, same type of deal, just adding an extra step or two. Alright, so make sure if you have any questions on this, you ask me in person. Otherwise, I would like you to work on the homework. So I'd like you to work on numbers, if you want to do the basic, do numbers 1 through 4. And this is for the solving proportions worksheet. So 1 through 4, I'd like you to try 10 through 12. I'd also like you to try number 15. And, well, I can actually put it up here for you. I believe I have it. So solving proportions worksheet. Gotta make sure which ones I want you to do. Alright. 21, 22, and 23, and 28. So we're going to erase this one. And we're going to do 21, 22, 23, 28. If you want to try the advanced, I'd like you to do numbers 1 through 3. 1 through 3. 10, 11, and then we're going to go ahead and do numbers 20 through 23. And 29 through 31. Alright. So each section has around the same amount. Advanced is going to be a little bit more challenging, but I'd like you to try, and if you want to challenge yourself even more, do some extras. But this is your homework on the Solving Proportions worksheet. Alright, I hope you have a good time.